All right, guys, this is going to be for homework 10, which is covering the idea of square roots. We did exponents right in homeworks 8 and 9, so now we'll be talking about square roots. Just to be clear, I'm going to throw some little extra here at the beginning. This is not something you need to know for your homework, but it is something that you're going to want to know just for the future. Square roots can be written as exponents. Again, you do not need to worry about this, okay? I'm not going to ask you to do this in class. We're not going to be converting exponents and square roots. But just FYI, remember in order of operations how it goes, grouping symbols and then exponents and roots at the same time. This is why, because they're actually the same thing. Again, this is not something you need to worry about in terms of being on the test or anything like that, but I think it's important to start off with just so you can understand square roots are just kind of a type of exponent. They're just weird. So we're not going to treat them as exponents, but to me, it's always a good thing to let students know that right away, square roots and exponents are actually the same thing. All right. So square roots, what do we know about square roots? Well, just in general, you guys know what a square root is. If I ask you for the square root of, we'll just say X for whatever number. What I'm asking you is what number times itself, right? What number times itself? And that's the key word there. What number times itself makes X, right? You know, basic stuff. You know these. I'll write down the basic roots you should know already here. All right. If you don't, make sure you know these. These will come in handy here. What times itself makes 0? 0, right? What times itself make 1 is 1. So we'll just go through the basic roots. You should know these already, but just, you know, just in case. What times itself makes 9 is 3. What times itself makes 16 is 4. These are considered the perfect roots, right? Clean roots, some people call them, perfect roots, whatever. All right. So I'm just going to go through and write these down. Make sure you know these. You should. This is part of like sort of a course prerequisite knowledge. We expect that you do know, your basic roots like 1 through 100 or whatever. Just because it helps in computation, it'll help, it'll keep it from slowing you down. I'm going to add one more in at the bottom. You might, oops, I goofed it up. I'm going to add one more in at the bottom you might not know. Let me see if I can do it correctly. That's the first part, right? So we got, 0 through 10 here, which these I do expect you to know. And it wouldn't hurt you to know 11, times 11 is. Because think about it, it goes backwards, right? 10 times 10 is 100, 9 times 9 is 81, 20 times 20 is 400. So it's good to know these things. Ignore that one there. I kind of goofed that up. And 11 times 11 is 121 and stuff like that. But again, there's only so far I expect you to know. I would go ahead and know that the root of 100 is 10 and the root of 400 is 20. You'll see why here actually very shortly when we start talking about kind of trying to bound roots or trying to figure out where roots would fall. But for now, anyway, learn those roots. Make sure you know those basic ones, and that'll help as we go here, okay? Couple properties about roots we'll start with. Again, this is actually a pretty short lecture, you guys, so hopefully that'll ease your burden a little bit. This will be a pretty short one. It doesn't mean it's, something you need to blow off. Pay attention to it, but this should be a pretty short one. Just recall from our discussion, actually this is from homework 1. Remember, we said the root of a number, if it has a whole number answer, right? Like the root of 9 is 3, that's rational. It's also could be an integer or a whole number, but the key here is it's rational. And remember, we said the root of a number that is not whole, or that does not, we'll say does not have a whole number answer. That's probably a better way to phrase it. Does not have a whole number answer. What did we call those? Those were irrational, right? So again, an example, the root of 9 is rational because it's 3, right? If I ask you for the root of 10, though, do you know that? Right? It's like 3 point something, but that's not a clean number. So it doesn't have a whole number answer. That would be irrational. This number here is irrational. So just a quick review on rational, irrational. Remember, rational meaning it can be turned into a fraction, and a regular number can be turned into a fraction. A number like root of 10 is going to give you a decimal that does not repeat and does not end, even if it ends in your calculator, it's just because the calculator ran out of room. So remember, square roots of numbers like that aren't clean, like the 10 and 11 and 12 and things like that, those are considered irrational. There will be a couple review questions on that in the homework. As far as negatives go on square roots, can you have a negative on the outside of one? Well, sure. It's just like having a negative on the outside of a parenthesis, right? It just sticks around. We didn't do anything with the negative. It's still there, and the root of 25 is 5. No big deal. What about if you have the negative on the inside of the root? Well, that's a little bit more of an issue, because what I'm asking you is what times itself makes negative 36, right? And certainly 6 times 6 does not work. That makes positive 36. Negative 6 times negative 6 does not work, because that makes positive 36. And you might say, oh yeah, well, 6 times negative 6, that works. Well, no, it doesn't, because remember what we said, roots have to be, what I'm asking you is what times itself, meaning what two of the same number can make negative 36. You will get it from a positive and a negative, but that's not a square root, because that's not the same number. You can't get it from two negatives, because that's a positive. You can't get it from two positives, because that's a positive. So if you slow down and you think about what I'm saying here, is you can't take the square root of negative numbers, because it's impossible to get a negative number from multiplying two positives or two negatives. The only way to make a negative number is by multiplying two different signs, and then they're not the same number. And that was the whole point, remember? Back to the root, what number times itself. So for a square root of a negative number, the official answer is no real solution. The homework might tell you to put DNE or something like that. That is technically not accurate, but it's all right. The same idea, it can't be done. No real solution. So a negative on the outside of a root, no problem. You just cannot take a negative or the root of a negative number, square root. What if there's a negative number and a positive number mixed inside though, right? So if I said the square root of, let's say, negative 2 plus 38, something like that, right? Don't jump the gun too quick. People sometimes here will say, well, negative under the root, can't do it. Well, let's work it out first. Negative 2 plus 38, that's just 36, right? And the root of 36 is just 6. So don't get too, overzealous here. Negatives under, you cannot take the square root of a negative number for the reasons we discussed. That gives you no real solution. You can take the root as long as the negative's on the outside. And even if the negative's on the inside, as long as it doesn't combine to a negative under the root, you can't take it. So just be a little bit careful with negatives. Negatives underneath are okay as long as it doesn't end up negative. If it ends up negative, then that's no good, obviously. All right, so just a couple basic principles of roots. We'll go over a few more here. Actually, I think there's just one or two more things we need to talk about before we get into the new stuff. Because like I said, at this point, I mean, honestly, you probably know most of this. You probably know what a square root is, and you know your basics and things like that. We're just, just reminding y'all. If I asked you to take the square root of a fraction, it's just the square root of the top over the square root of the bottom. So for example, if I said root of 1 over 81, right? Well, that's the root of 1 on top of the root of 81. You don't need to write that, but that is what's happening. The square root of 1 is 1, and the square root of 81 is 9. So no big deal. Just take the square root of the top, square root of the bottom. Nothing crazy there. There's a few questions in the homework that will ask you to bound a square root. I think it's on a ruler actually. It'll say like, between what inches does this fall? So for example, they'll say the square root of 24, and they'll say, between what numbers does this fall? And I think they use a ruler, but it could just be a number line. Between what numbers does this fall? Meaning like, is it between 2 and 3? Is it between 4 and 5? Is it between 9 and 10? That kind of thing, right? If you put the square root of 24 into your calculator, it's just going to give you a bunch of decimal junk. So we're asking you without a calculator, because remember, that's the whole idea of the course, between what numbers does this fall? So what I would do is think about it like this. What's the first root you know before 24? The square root of 24. What's the first clean root you know before that? Probably 16, right? I know the square root of 16, which is 4. Then we get the square root of 24 somewhere after that. And then the next one I know after that is the square root of 25, right? I know the square root of 16. The next one I know is the square root of 25, which is 5. So 24 falls somewhere between 4 and 5. Obviously much closer to 5 than 4, because 24 is closer to 25. So this should be 4.8 or 4.9 something. But we're not asking you to come up with a decimal. So you don't need to worry about that. All we're asking you to do is to bind it. Between what two numbers does this occur? Okay? And this is why I asked you for that large root, or I told you to memorize that large root earlier, because let's say I gave you the square root of 169. Now pay attention to the instructions. If it says evaluate, they're sort of giving you a hint that that's going to come out to an even answer. If it says simplify, they're kind of telling you it's not going to come out to an even answer. All right. Well, let's say you gave them the square root of 169, and maybe you want to find between what two numbers that falls, or something like that. This is why I gave you the root of 400. You know the root of 100, which is 10. Now, hopefully, you know the root of 400. Remember, we mentioned that one earlier, which is 20. So this falls between 10 and 20 somewhere. And, at that point, you're just limited to, 11 through 19. You can memorize those roots. I have had students do that in the past. They just memorized 1 through 20. 11 times 11 is this, 12 times 12 is this. And that is probably the most expedient way to go. You could ballpark and say, well, look, it ends in a 9. So this is either from something that ends in a 3, 13, right? Because 3 times 3 ends in a 9. Or, be careful, it could end in a 7, because 7 times 7 ends in a 9, 49. So it's either 13 or 17. But how clever you get with it at that point is up to you. I just wanted to make sure you understand that it is bounded. The root of 100 is smaller, and that's 10. The root of 400 is bigger, and that's 20. So the root of 169 falls between 10 and 20. If you asked me to put it somewhere on a ruler, I'd put it between 10 and 20. And then again, you can start screwing around and try to figure out exactly what it is, but the question will most likely just ask you between what two roots does it fall. So just a little binding. It's good to know a root above and a root below. So just pay attention to that kind of thing. I think there's a few questions in the homework about that. Nothing crazy. All right. So that sums up the root review. Some of that may not have been reviewed for y'all. I get that, but that's okay. Let's get into the new material, the bit you may not have done before. And hopefully it won't be too crazy, especially if you paid attention in other lectures. So the new idea in this homework, besides just going over some basic root stuff that you should know, is how to simplify a square root. In the last problem, I mentioned that if it says evaluate, well, they're probably telling you it has a value like 3 or 10 or something like that. If it says simplify, the implication is that it's not going to have a clean value. So let's just say something like the root of 12. All right, it'll say simplify the square root of 12. So pay attention to the instructions. If it says simplify, that's a different game than if it says evaluate. So the square root of 12, you could bound it if you want to. This is not necessary. I'm just making the point one more time. The one I know below that is 9, which is 3. I know a root above that, which is 16, and that's 4. So the square root of 12 is between 3 and 4. But that's not what simplify means. Simplify means clean it up. It doesn't mean give me a value. So while it's good to know that 12 is between 3 and 4, it's not really the point of the question. So here's what we're going to do. We're going to take 12 and we're going to do prime factorization. And this is what I said. If you paid attention in previous lectures, I think this question was on your test, how to prime factor something. It's the tree, right? So what we're going to do is take 12 and we're going to break it down. Just like we did before when we were doing GCF and LCM and stuff like that. So again, 12 could be 4 and 3. You could use 6 and 2 if you want. Break down 12 because it's gone. 3 does not break down, but 4 does. It breaks down into 2 times 2. So 12, if you think about it, what I'm saying here is the square root of 12 is the same thing as the square root of 2 times 2 times 3, right? We all agree? 2, 2, 3. Now that's not simplified, that's just rewriting it a different way. You haven't simplified anything. Now here's where the rules come into play. Here's where the new rules come into play. What you're gonna do is look for pairs of the same number, because what did we say a square root was earlier at the very, very beginning of the lecture? What did we say a square root was? What times itself? Well, so what you're looking for is numbers times themselves, and I see it right here. I got a pair of 2s. So what I'm gonna do is take this pair of 2s and I'm gonna bring it out. The issue is it only comes out as a single 2. Every pair you take only comes out as one number. Because think about it. I mean, you don't need to go through all this in your head, but what's 2 times 2? 4. What's the square root of 4? 2, right? But rather than go through all that, what we do is we say, well, here's a pair of 2s, so I'm going to bring it out, but every pair comes out as a single number, and then we have a 3 left behind, and that's your answer. Now, whether you think that that's simpler or not is, unfortunately not up for debate. So the square root of 12, if I asked you to simplify it, your answer would be 2 square roots of 3. That is what we mean by simplifying the root, taking every number you can out and leaving as little behind as possible. Okay, so we'll do several examples here. So that was a little confusing. It's all good. But just make the point. You break the number down using prime factorization and then look for pairs of numbers, 2 and 2, 3 and 3, 5 and 5, whatever. Every time you have a pair, it comes out, but only as a single number. That's the key, okay? So let's do a couple practice problems, and then, my friends, that's it for the day. Not much going on here. That's nice, isn't it? Little break. Well, let's get through it first. So let's do square root of 18. All right. So first thing to do is take the number 18 and use prime factorization to break it down. 18, we could use 3 and 6. Or 9 and 2. Remember, what order or what breakdown you choose doesn't matter as long as, you know, the breakdown you're choosing is legitimate. 3 can't be broken down, but 6 can into 3 and 2. So what we have here, the root of 18 turned out to be a 2 and 2 3s. So what I like to rewrite it, 2 times 3 times 3. And remember, it is still the root of 18. That's all we've done is taken the root of 18 and just rewritten it in prime factorization. The root is still there. Then we go through and look for pairs. Here's a pair of 3s. Every pair comes out as a single number, and that's the key. So I'm not taking 2 3s out. I'm taking 1 3 out for the pair, and that 2 is going to stay behind. And so the root of 18 turns into 3 root 2. So make sure this is making sense to you. Take a minute. These actually were, you know, backwards of each other, right? We had 2 2s in the last one. This time we had 2 3s. You know, it is what it is, okay? Let's go ahead and do another one. Let's do square root of 72. And again, the instruction here would be simplify. So take 72, break it down. Any way you know how, 9 and 8 maybe. And then 9 can be 3 and 3. 8 can be 4 and 2. And then 4 could be 2 and 2. Be careful, make sure you use the multiplication and division here. So, excuse me, 72 had a couple or several numbers, a 2, a 2, a 2, a 3, and a 3. So the root of 72 we could write as, and I like to do these in order so you don't mess it up, 2, 2, 2, 3, 3. All right. So now we're looking for pairs. There can be more than one pair. It's no big deal. Here's a pair of 2s. So that comes out as a single 2. Here's a pair of 3s, so that comes out as a single 3. And this 2 here is the only one left behind. So on the outside of the root, we have a 2 from the pair, a 3 from the pair, and this 2 that was left behind just stayed there. If you have multiple numbers on the outside, the whole thing is multiplication, right? Everything is multiplied. 3 times 6, 3 times 2, 3 times 3. It's all times. So if you brought out a 2 and you brought out a 3, 2 times 3, you brought out a 6. And what you left behind was a 2. So hopefully that's making some sense. Okay, we'll do a couple more examples here, but that's really it, guys. If you can hang on to what I'm doing here, that's really all we're doing is in terms of the new material. Okay. So what if it's a large number? Well, it doesn't really change anything at all. So let's do square root of 300. I would, you know, your breakdown can take a long time if you sit there cracking at it with 2s and stuff, but, you know, it's up to you. So 300, let's go ahead and just do 30 times 10. That's the way I like to do it. But again, how you break this down is totally up to you. As long as your breakdown is legitimate, you should get the same numbers. 10 would be 2 and 5. 30 would be 6 and 5. And 6 would be 2 and 3. So take a minute, make sure you agree. I got 2 2s, 1 3, and 2 5s. So the square root of 300 turned into 2, 2, 3, 5, 5. Make sure you count for all of them. 1 2, 2 2s, 1 3, and 2 5s. Now we're looking for pairs. So here's a pair of 2s that comes out as a single 2. Here's a pair of 5s that comes out as a single 5. Remember, they are going to multiply. And the only thing left behind was the 3. So just clean the outside up. You took out a 2, you took out a 5. So what you took out was a 10, and the 3 stays behind. This is not the only way to do these. You might be sitting there going, well, 300 is 100 times 3, and the root of 100 is 10. I'm done. Yeah, true. I don't care how you do them. But just so you know, in the future, meaning like MGF1100, MGF1100, you're going to have to break down cube roots and fourth roots and things like that. And this is the method we use for higher level roots. Is there an easier way to do square roots? Yeah, probably. But this method that I'm showing you now works for any root. If we were doing a fourth root, you'd be looking for sets of 4 of the same number. If we were doing a cube root, you'd be looking for sets of 3 of the same number. So the reason I'm showing you this technique, although it may not be the quickest, is that this is the technique we use on higher end roots too. So when you get into classes in the future and the teacher mentions, using this method, you'll be familiar with it. Let's do one more here. All right, let's do a couple more actually. Let's do 2 more. Let's do the root of 30. This is a nice mundane one that really messes people up. I think I threw this on a test a couple of semesters ago and the results were kind of crazy. Because people, they had the answer, but then they didn't trust it. And that's part of it. You got to be confident enough with what you're doing to know when what you've done is right. So 30, we can break that down to 3 and 10 maybe. And then 10 we can break down into 2 and 5. So 30 is the root of 2 times 3 times 5, right? 2, 3, and 5, the 10's gone. And you say, well, all right, there's no pairs here, so now what? Well, then that means nothing comes out. You couldn't take anything out, so all you're left with is root 30 in the end, because 2 times 3 times 5 is 30. So sometimes roots cannot break down. They'll ask you to simplify a root, and it does not simplify because nothing comes out, in which case the answer is what they gave you. Think about the root of 10. How would you break 10 down into 2 and 5? Would you have any pairs there? Nope. So the root of 10 cannot be broken down. There's several roots that cannot be broken down. The root of 10 cannot be broken down. The root of 15, right? Because 15 is just 5 and 3. The root of 6, because that's just 2 and 3. So there's a lot of roots that don't simplify. So don't panic if that happens to you. There's nothing wrong. It just means that root doesn't simplify. The only other thing I wanted to mention here is what to do if there's numbers on the outside of the root already. And the good news is it's not very different from what we just did a few minutes ago. So let's say I said 4 root, what's a good one? Let's do 24. And it said simplify. What you need to do is view this as a 4 that was already taken out. We took out a 2, we took out a 3 or whatever in the previous problem. So just pretend somebody already took out a 4 and then continue on as normal. So the first thing we're going to do is break down the 24, which could be 2 and 12. Again, how you break it down is up to you. 12 could be 4 and 3, and 4 could be 2 and 2. Right? So 24 breaks down into 2, 2, 2, and 3. 3 2s and a 3. This 4 on the outside I've not done anything with, so we'll just worry about that in a minute, okay? So right now we have the 4 on the outside, and then underneath the root I have 2, 2, 2, and 3. Okay? So all we need to do now is what we've been doing before, look for pairs. I see a pair of 2s here, so that comes out as a single 2. And the 2 and the 3 inside do not pair off, so they stay behind. Think about it, right? This 2 and 3 are not a pair. There's no other number, so they stay behind. So what you had under the root was a 2 and a 3. What you had on the outside of the root was the 4 that was there originally, right? Which we never did anything with. It's just been sitting there this whole time. And the 2 that you just brought out. Remember, everything's just multiply. So if you had a 4 already and you brought out a 2, 4 times 2 is 8. And on the inside, you had a 2 and a 3 left, so it's 6. So really having a root, or excuse me, a number on the outside of the root doesn't really change anything. It's part of the answer. You have to multiply it back by whatever else you brought out, okay? So whatever number you have on the inside of the root, which is called the radicand, by the way, it's kind of a crazy word, but that is technically its name, just so you know. That's the radicand. The root, the number underneath the root, the radicand, you simply break down like normal, pull out whatever you pull out, leave behind whatever you leave behind, and then just make sure that the number that was already out there is brought back down. You took out a 2, there was already a 4, 4 and 2 is 8. You left behind a 2 and a 3, which gave you 6. Okay, so that's simplifying square roots, guys. Hopefully that wasn't too big a deal. Hopefully the homework won't be too big a deal for you. And that'll wrap us up with that, and I'll see you in the next one.